IFR training videos, by
Toga Thrust.
NDB approach at Merville, Lfqt.
As usual, at the end of the cruise, where we reach the equitime point between the last cruise alternate and the destination, we compute the top of descent. But it can be earlier depending. At first, we listen to the ATIS, note the letter, runway in use, type of approach in use, wind and crosswind component, visibility and ceiling, do we have the required minimums? Temperature and dew point, QNH, trend, special weather. Then we take care of the fuel, sufficient and balanced? How much extra fuel do we have? How much holding time? NOTAMs, check the NOTAMs in the flight folder. Briefing preparation, IFRBT, initialize, flight plan, radios, bugs, transponder in a structured manner. Looking at the chart, we will insert the NDB approach in the G1000 for information as we cannot fly an NDB approach via the G1000. For the VORs, we need the Mike Echo Romeo DME and, eventually the radial 294 degrees from Lima Echo Quebec. Some companies forbid to use the bearing 1 for the NDB, others not. We will use the bearing 1 for the NDB, so we can put the bearing 2 on nav2 with the ILS Mike Echo Romeo to have a computed mileage if the DME fails. Then we need the VOR Lima Echo Quebec on nav1 for the radial 294 degrees to confirm the position of the NDB Mike Romeo Victor. The VOR setup will then be nav1 on Lima Echo Quebec with the ILS Mike Echo Romeo on standby, nav2 on ILS Mike Echo Romeo active with VOR Lima Echo Quebec on standby as we do not need another VOR. Then, the DME to read should be on nav2, we will have to change that setting in the ADF, DME function of the G1000. Be careful with that killing switch and remember it is on nav2 and not on nav1 for further navigation if any. After the navs, we take care of the comms. We are still on Lille approach on 126.480 active on COM 1, next frequency is Merville Tower on 119.075 on standby COM 1. Active COM 2 is emergency 121.500 with the standby remaining on the ATIS frequency 127.905, do not confuse with Lille ATIS on the chart. We then switch to the PFD menu. Map inset on 5 nautical miles range, with at least topo. PFD menu, wind, select option 1, 2 or 3 you like. Bearing 1 on ADF, bearing 2 on nav2. CDI 1 set for the moment on 216 degrees for the holding, racetrack. It will be set later on the radial 294 degrees. ADF, DME, ADF set on Mike Romeo Victor 404 MHz and identified with the Morse code. Unlike the VORs, the NDBs don't have an automatic ident. DME, set on nav2 as said before. Transponder, still active on alt mode. Timer, references, timer reset and ready if needed. Bugs set and minimas entered for the approach. This complete the preparation phase of the briefing. But settings are all up to you as long as it is logical and reflects the sequence of events. We could have chosen to set the bearing 1 on nav1, bearing 2 on ADF, CDI 2 active, nav1 on ILS for distance, standby on Lille VOR, nav2 on Lille VOR with ILS on standby for redundancy. In this case, DME setting stays on nav1. Now that the briefing is prepared, let's give it to our flying partner. We are inbound to Merville for an NDB approach runway 22. ATIS's information Charlie, runway in use 22, NDB approach in use. Wind reported calm, visibility 1,200 meters, RVR 1,600 meters, ceiling overcast 500 feet, temperature 3 degrees, dew point 1 degree, QNH 1013 hectopascals, no significant change. Wind within limits, no crosswind, we have the minimums for the approach. Fuel sufficient and balanced, remaining holding fuel 1 hour. NOTAMs, grass runway closed, poppy runway 22 out of service. Briefing, we are approaching the initial approach fix from the west at 2,500 feet QNH, initial approach fix altitude. We have to enter the racetrack on radial QDR 036 degrees. So, holding preparation 5 points, reduce the speed, check the facility frequency, check bearing set on frequency, set CDI tail on holding radial, compute the entry. Here it will be a parallel entry first track 036 degrees, left turn. We brief the chart Merville France NDB Zulu runway 22. Chart 16-2 effective date 26th of January. Cat A and B aircrafts. NDB frequency 404 MHz, final approach course 216 degrees, initial altitude 2,500 feet, DA, MDA 540 feet, airport elevation 61 feet, minimum sector altitude 2,500 feet, 2,700 feet for the go-around. Approaching from the west, overhead the beacon, enter the racetrack via a parallel entry as computed, angle of difference 60 degrees, 1/3 equals 20 degrees, so interception track will be 0.16 degrees. After the entry, passing the beacon outbound, we follow the racetrack outbound leg until 8.4 DME of Mike Echo Romeo ILS. Then right turn to intercept the inbound course QDM 216 degrees at 2,500 feet. Final approach fix is at 6.6 DME ILS. So at 7.6 miles, set flaps approach. Start descent at 6.6 miles on a 3.49 degrees, steeper than standard, 620 feet per minute with a ground speed of 100 knots. Check overhead the NDB at 1,410 feet. Descend to minimums 540 feet on CDFA. We need an RVR of 1,500 meters that we have. In case of a go-around, climb on 216 degrees QDR from NDB to 1,500 feet, then turn right to NDB climbing to 2,500 feet, do not turn before passing the missed approach point, climb to 1,700 feet before level acceleration. The DME is required. If local ATS is not available, obtain Leal altimeter setting from Leal ATIS or Leal approach, pilot controlled lighting. If local ATS not available, air-to-air communications in French only. Highest obstacle on the chart is 1,250 feet. Descent is according the descent scale centered on Mike Echo Romeo ILS DME. Runway has high intensity runway lights, runway edge intensity lights and a poppy, and op by NOTAMs. In case of downgrade, request an ILS approach runway 22. If reset and briefed before 1,000 feet AGL, continue, if not, go around. Performances, landing distance beyond runway threshold is 1,720 meters, runway width is 30 meters. We need 700 meters length. After landing, vacate right on Bravo 2. Threats, low temperature and icing threat. Specials, no poppy available. Do you have any question? No question? Okay, next step will be overhead the beacon. Turn left heading 016 degrees for racetrack entry. Overhead the beacon, turn, to the computed heading of 016 degrees. Time, start for 1 minute for the entry. Twist, heading bug on 016 degrees to be corrected for the wind. Talk, entering the racetrack. Throttle, check speed versus power and any sign of icing. Next step, on the QDR 216 degrees and 1 minute outbound, turn left to the beacon. You are cleared for the approach. Contact Merville on 119.075. Next step will be, at 1 minute outbound, turn left back to the beacon. At the end of the minute, turn left back to the beacon. Next step will be, overhead the beacon, turn right on outbound track, 036 degrees heading corrected by the wind. Overhead the beacon, turn right to outbound track. Turn, to the right heading 036 degrees to be corrected for the wind. Time, stand by for a beam position. Twist, set heading bug. Talk, outbound on the racetrack. Throttle, check speed versus power and signs of icing. Next step, at 8.4 miles, turn right to intercept inbound QDM 216 degrees. As we see, the wind is calm, so no correction to be applied. We can continue as is until reaching the point 8.4 miles. Start the chrono to check our position according the teardrop radial. Next step will be at 2/3 of 1 minute, that is 40 seconds, check the tail of the needle is at 40 degrees to the holding radial, 10 degrees before the teardrop. We see that we reach the position 40 degrees before the holding radial on the tail of the needle already at 28 seconds. It means that we will reach the teardrop too early, or that we are too much inside the holding pattern and that we must change the heading to the exterior of the pattern. We keep that correction until the end of the minute to reposition ourselves correctly on the pattern. Then, as we have to continue till 8.4 miles, we will return to the outbound heading. Next step will be, at 8.4 miles, turn right to intercept QDM 216 degrees. At 8.4 miles, turn right to the interception heading. Time, reset and ready in case of need. Twist, set the heading bug, set the CDI on 294 degrees. Talk, turning inbound final. Throttle, check speed versus power and sign of icing. Next step, intercept QDM 216 degrees. Established on QDM 216 degrees. Next step will be, 7.6 miles, set flaps approach. (7.6 miles, flaps approach. Next step will be 6.6 miles, gear down and descent. (6.6 miles. Gear, down. Glide, start descent at 650 feet per minute. Go timer, not needed. Go around, altitude set at 2,500 feet. Green lights, check gear and flaps lights. Next step will be, 5 miles at 1,920 feet. And we continue tracking the QDM as precisely as possible. "5 miles, we are 140 feet too high, we increase the rate of descent to catch up the slope. Next will be 4 miles at 1,550 feet. As the CDI is approaching its centered position, we know that we are approaching the beacon, at 3.6 miles to Merville ILS. 4 miles, still 150 feet too high, continue the high rate, our rate of descent is too small, our TOS is nearly 130 knots, so we should be around 900 feet per minute to catch up. Next step will be 3 miles at 1,180 feet. 3 miles, no change, we are still 140 feet too high on the slope. Next step will be 1,000 feet AGL for approach ban. (1,000 feet AGL. We have the minimas, continue. 500 feet above minimas, stabilized, checklist complete, cleared to land. Next will be 2 miles at 800 feet. 2 miles, on the slope. Next will be 100 feet above minimas, start looking outside. (100 feet to minimas. Next will be minimas. Minimas, go around. QDR 216 degrees to 1,500 feet, then right turn. Report going around. 1,500 feet, turn right to the NDB, climb 2,500 feet. After takeoff checklist. Turn, the NDB. Time, reset and ready if needed. Twist, heading bug. Talk, already reported and clearance received. Throttle, check speed versus power and sign of icing. Next step, overhead the beacon, perform entry parallel, QDR 036 degrees, left turn. Now, reaching the beacon, you may 1. Restart another approach with a new clearance by ATC. 2. Enter the hold, not the racetrack, outbound will be 1 minute, and assess the situation, holding fuel. 3. Depart to your planned alternate. This module is now completed.